Why is Git commit history immutable? Imagine trying to change a page in a printed book after it's been published. You can't because the original is already out there, unchangeable. That's how Git keeps track of your code. When you make a commit in Git, it's like taking a snapshot of your project at that moment. Each snapshot gets a special code called a cryptographic hash, which is like a digital fingerprint. This hash is created from everything in the commit: the files, the message you wrote, the author, the time, and the links to previous commits. Because the hash depends on all these details, even a tiny change would create a completely different hash. So, if you try to change what's inside a commit, it's like changing the fingerprint it no longer matches. This design makes commits unchangeable once they are created. If you want to fix or update a commit, Git doesn't go back and edit it. Instead, it creates a new commit with a new hash. The old commit stays exactly as it was, like a permanent record. This is very important for teamwork. When many developers work together, they need to trust that the history of changes is accurate and unaltered. If someone could change past commits, it could cause confusion or even mistakes in the project. In development workflows, this immutability helps keep a clear history of what was done and when. It makes debugging easier because you can see exactly what code was in each commit. It also helps when you need to go back to a previous version or verify what was deployed. When working on backend projects like Apis, databases, or Server Logic, knowing that your commit history is reliable is a big advantage. Sometimes developers rework their local history by rewriting commits, like squashing or rebasing. But they usually do this only on their own branches. The shared branches that everyone pulls from are kept and changed to preserve trust. This way, everyone can see a consistent story of how the project evolved. In short, Git commit history is immutable because each commit's identity depends on its entire content and parent links, secured by a cryptographic hash. This makes the history trustworthy, reliable, and a solid foundation for managing backend development projects.